Hello and welcome. We're talking about the dinosaurs. For millions of years, evolving into a stunning variety of shapes and sizes, from the towering, long-necked Brachiosaurus to the ferocious, razor-toothed Tyrannosaurus rexus. Their story is one of incredible adaptation, epic battles, and a sudden, mysterious disappearance that has captivated scientists and dreamers for centuries. Get ready to journey back in time and discover the lost world of the dinosaurs. This book is a tale of dinosaurs, who they were, what they did, and how they did it. But more significantly, it is also a tale of natural history. Dinosaurs enrich our concept of the biosphere, the three-dimensional layer of life that encircles the Earth. Our biosphere has a 3.8 billion year history, and we and all the organisms— To be unaware of the history of life is to be unaware of our organic connections to the rest of the world.
Dinosaurs have significant lessons to impart in this regard, because, as we learn who dinosaurs really are, we can better understand who we really are.
Science depends upon imagination and creativity.
In the following pages, we hope to build a sense of the intellectual richness of science. That we even know there ever were such creatures as dinosaurs is due to dumb luck.
Some dinosaurs just happen to be preserved as fossils, the buried remains of organic life.
Dinosaurs last romped on Earth 65 million years ago. This means that their soft tissues, as muscles, blood vessels, organs, skin, fatty layers, are, in most fossils, long gone. If any vestige remains at all, it is usually hard parts, generally bones and teeth. Hard parts are not as easily degraded as the soft tissues that constitute most of the body. Before burial, consider what might happen to a dinosaur or any land-dwelling vertebrate after it dies.
Carcasses are commonly disarticulated, dismembered, often by predators,
and then by scavengers ranging from mammals and birds to beetles. As the nose knows,
most of the heavy lifting in the world of decomposition is done by bacteria that feast on rotting flesh.
Some bones might be stripped clean of meat and left to bleach in the sun. Others might get carried off and gnawed.
Sometimes the disarticulated remains are trampled by herds of animals, breaking and separating them further.
So the sum total of all the earthly remains of the animal will end up lying there.
If the animal isn't disarticulated right away, it is not uncommon for a carcass to bloat, as feasting bacteria produce gases that inflate it, leaving bones, tissues, ligaments, tendons, and skin hard and inflexible.
Burial. Sooner or later, bones are either destroyed or buried, if they aren't digested as somebody's lunch.
Their destruction can come from weathering, which means that the minerals in the bones break down. But the game gets interesting for paleontologists when weathering is stopped by rapid burial. At this point, they, the bones, not the paleontologists, become fossils.
A body fossil is what is produced when a part of an organism is buried.
We distinguish these from trace fossils, which are impressions in the substrate left by an organism.
After burial, bone is made out of calcium-sodium hydroxyapatite, a mineral that weathers easily.
This means that, after fossilization, many bones no longer have original calcium-sodium hydroxyapatite present.
This is especially likely if the bone comes into contact with fluids rich in dissolved minerals,
such as commonly occurs after burial. If, however, no fluids are present throughout the history of burial, from the moment that the bone is buried to when it is exhumed by paleontologists, a time interval that could be measured in millions of years. The bone could remain unaltered, which is to say that original bone mineralogy remains. This situation is not that common and is progressively rarer in the case of older and older fossils. Ancient, unaltered bone, floor, and even tissue do exist, and are crucial for our understanding of the growth of bone tissue, other soft anatomy, and the discovery of genuine red blood cells and connective tissues from Tyrannosaurus. Most bones are altered to a greater or lesser degree. Since bones are porous, the spaces once occupied by blood vessels, connective tissue, and nerves fill up with minerals. This situation is called permineralization. Bones can also be replaced, in which case the original bone minerals are replaced with other minerals, retaining the exact original form of the fossil. Most fossil bones undergo a combination of replacement and permineralization. The resultant fossil, therefore, is a magnificent natural forgery, chemically and texturally not bone, but retaining the exact shape and delicate features of the original bone. Other fossils' bones are not all that is left of dinosaurs. Occasionally, the fossilized feces of dinosaurs and other vertebrates are found, called coprolites.
These sometimes impressive relics can give an intestine's eye view of dinosaurian diets.
Likewise, as we shall see later in this book, fossilized eggs and also skin impressions have been found, in which case the original bone minerals are replaced with other minerals, retaining the exact original form of the fossil. The single most important type of dinosaur fossil, other than the bones themselves, is trace fossils. Dinosaur trace fossils, sometimes also called ichnofossils, come as isolated footprints or as complete trackways, a mold or impression of a dinosaur footprint. We also find casts, which are made up of material filling up the mold. A cast of a dinosaur footprint is a three-dimensional object that formed inside the impression, or mold. In the last 20 years, the importance of ichnofossils has been recognized. Ichnofossils have been used to show that dinosaurs walked erect, to reveal the position of the foot, and to reconstruct the speeds at which dinosaurs traveled. Trackways tell remarkable stories, such as that fateful day 70 or so million years ago, in which case the original bone minerals are replaced with other minerals, retaining the exact original form of the fossil.
So if the fossils are buried, how is it that we find them? The answer is really in the luck of geology, if fossil-bearing sedimentary rocks.
Dinosaurs walked over the exposed fossils of earlier ancestors, now lost to eternity. The next part of this chapter is coming tomorrow. Don't forget to like and subscribe. Thanks for watching.